Welcome back. It has been a long time. So we have been learning Python for quite some time now, and we are going to talk now about something we have been using till now. We have been using functions for quite some time, and as a developer, you should probably be interested in actually creating some, right? So the idea is that pretty much in any language you take, right, there is a way to create functions, or to put it in developer language, to define functions. So we'll start off with functions in Python, right? So we'll also be covering modules and packages. These are mechanisms in Python to create modularity, and we'll talk about each of these things in detail, but we'll start off with functions because functions are the basic block, right? As usual, I learn, right? So actually practice with me. These videos down the line will have me actually writing code. So I would love you to actually start writing code with me. So that is the way to learn best, and obviously try out different things which I suggest as part of the video. Now let us get to functions. Like I said before, every language supports both usage and definition of functions, creation of functions, right? What are functions? Functions are a chunk of code, are chunks of code to tell Python to do something, right? So they are one way to reuse code. You can use functions in your programs again and again. That's the idea, right? So I will try to define function as a more stringent developer-like language definition I will provide now. So a function is a self-contained block of code that does a task, right, or a related group of tasks, right? So it is a self-contained block of code. You know block. So block of code, self-contained. It does one task or a group of related group of tasks, and that is a function, right? Now we have already seen a lot of built-in functions. We have seen id, we have seen len, we have seen any, many of these are there, right? The code for this function, these functions, resides somewhere. You don't know where it is, or you even don't know how it works, but you know how to use them. For doing that, you just need to know its interface. That's basically the name, and then the argument it takes and the values it returns. And remember, any function may have no arguments and may not return anything also, right? So this is typically a function, the way you use a function. So when you call a function, the program execution goes to the function. So if you have, this is your program and you're calling a function here, from there the control will go to the function. So along with, so when it goes, it will take anything which you send with it, that is the parameters you pass. Once you do that, this task, so inside this function, it will do its task, hopefully something useful, and then once it has completed it, it will return back to where it was called from, right next to the next line, to start off where it left. So this line, if you assume that this is the line which actually has the function code, and this is where you have the actual function, there is a call, and the function will execute like this. All these lines will execute, and once after that it will come and join next line, right? And function may also return back something, but it's not necessary, right? A function defined by you will work the same way. You call it, it gets executed, and the control returns back. Of course, since you wrote it, you know what it does and where it is, right? So if it's your own function. So let us now talk about the importance of functions, right? All languages support functions, right? They may be called differently in different languages, but they are there. They are supported by every language, every programming language. Some of the common synonyms for functions are, they are called subroutines in some languages, procedures, methods, subprograms. These are all synonyms. Many languages just use functions also. So these are all synonyms They are roughly mean the same thing. So before we figure out how to define them, let us understand why we define them. And remember, why is always the most important question. We forget about it most of the time, but that's important. We keep on focusing on the how rather than the why. So here I had given a hint earlier that about why we define them, right? I had told you a little bit, but let us dig deeper into it. So the first idea is abstraction and reusability. So let me paint a picture. You write some useful code, say how to calculate compound interest or find out all the prime numbers from 0 to a given number. As you keep writing more and more programs, you might want to do that particular task again, right? So you copy and paste, right, that code to another part of the program. Problem solved. You keep doing this for some more time. Now you want to change that task or that piece of code, say slightly. Say apart from returning positive prime numbers, you also want to return the negative ones. What do? You find all the places this code was written, like you copy paste in multiple places and change it everywhere. That is really boring, right? And what if you miss one of the cases? Then you will have a bug, right? Bug is another name for a mistake in developer language, which leads to wrong results, right? So you will have a bug if you miss it. Instead of doing all this, what you could do is you could define a function which does this work. Let us call it find prime numbers. Once you define this function in one place, you can call this everywhere, right? And the same code will execute. When you want to make a change to return negative prime numbers, you just have to change that one place, that function, and then you are done. Wherever you wanted work to happen in a new way, you just change in one place. That's really cool, right? This taking out of functionality is also called abstraction of functionality. This taking out into a function is a very powerful thing. It allows us to follow software development principle of dry. Don't repeat yourself. D-R-Y, dry. So I think that should be enough. That should convince you that functions are the best thing in the world. That is one good enough reason for me. But of course there is more, and we will talk about that. So let me go to the next point, which is modularity, right? Just going to clear this up. Functions allow us to break things down into small manageable pieces. So let us say you are building a program like this, right? Now there are a lot of lines of code here, right? Let us say first one is just about collecting users, a lot of input from the users. The second set of statements is about doing some calculations, and then you print out a lot of results saying these are the different calculations I did, right? Now if you write it the way I'm showing it to you, we see a long set of statements here, right? And in order for us to understand the code, what we have done is we have used comments and we have put some extra lines in between. Now these are good methods, but as you keep changing and keep growing the program, it won't be easy, right? Because comments could go out of date, comments don't execute, right? It can go out of date. So it becomes more and more difficult to understand and manage this. A better solution would be to do this. So this is what you had, you can change it to like this. What it does is you have three functions or methods with names: take user input, do calculations, and print results. And the main program is just calling these functions. So this is called modularized code. So instead of writing line after line of the code, which means you have to read it like that as well, like line after line after line. We are split it into small focus functions which do one thing, right? The name of the functions tell you what they do as well. So you need to name the functions well. And the main program is a simple 3-liner just calling the functions. When you read this code, this main program, there are only 3 lines, and that gives us a very good idea what the whole program does at a high level. If you dive deeper within each of these functions, you can know more, right? So now you are able to read this code top down, in the sense that you see at a higher level of understanding. You see the main code, that is these 3 lines. These lines are getting close with this. So these 3 lines tell you, okay, these are the 3 big steps I do, right? And then when I want to understand, oh wow, what kind of user input are we taking, then I can get into these functions. So this kind of reading is called top down, and each function is doing only one thing, and that's called single responsibility principle, right? We earlier saw dry, and this is SRP. This is another kind of principle which developers follow. Single responsibility, which means every function has one thing to do, one single responsibility. Actually, what happens with single responsibility is that you can take that concept to every level, but I think that's diverting us from what we want to learn, functions right now. So functions allow us to do these specific things. They allowed us to modularize and follow the single responsibility principle, so that it's easier for us to understand and change them, right? Now, when you looked at this code, you might have seen the keyword def, right? This def is used to define functions. More on that very soon. So, idea of splitting work up into steps is not something new. You surely do it all the time. Think about how you get your bag ready for school. Steps are: take out books from the bag, look at the timetable, arrange the required textbooks into the bag, arrange the required notebooks into the bag, and check and arrange your pencil box bag into the bag, and you're done. So these are the steps you follow. Now, instead of feeling this one big task of how do I manage this big bag and all that, you split into small tasks, subtasks, and you finish the entire thing. This applies to programs also. So this is what modularity is, right? The last point, which is related to defining functions, making it useful, is called the namespace separation. What is a namespace? Namespace is a region in your program in which any defined variable or variable identifiers have a connection and a meaning, right? So what does that mean? In a normal program, there is only one namespace, which is the program itself, right? Like we have seen we already seen a lot of these programs you have written, and that program is the only namespace. We call it the main or the global namespace for convenience. So I might be using main sometimes, I might be calling it global namespace, but they mean the same thing. That's the entire program's namespace. So when you define a function, what you're doing really is creating a separate small region or namespace, and that is separate from the main program. So if you, instead of defining say a equal to 0 somewhere, so let me just do a small, let me get into the Python shell. I need to obviously clean this up, and let me go to ptpython. Now what I'm trying to say is, within a function, if you define a variable, that is defined in a different namespace, and that is understood by the function, and it won't be confused with the names or the variable names which are defined in other namespace like the main program itself. So a function can define variables with whatever names it wants without worrying about the same name being used outside the function. So I'll show you now. So I have this variable now on the REPL. This is sort of the outer Python shell, right? So I have defined a. Now I'm going to define a function def fn1 function1, just a rudimentary name, and I'm going to define the same a equal to 22. Now if I do print of a, this is, I have defined a function now. Now I'm going to do print a. So this actually print a outside refers to the a which is defined here, right? But when I run fn1, it actually refers to this a inside the function, right? So if I change a to 32 outside, and then again if I print, now a is 32, but if I go back and print, call the function the way I normally call it, I still get back my old 22 because the function is referring to its own defined variable, right? So the function will give you more freedom and will reduce unnecessary and unexpected errors. Oh, if functions were sort of accessing everything, and or if you had to reassign stuff everywhere, then you would end up with a lot of errors, right? The functions have its own namespace. It changes things inside it. I mean, there are ways to change stuff outside, but typically you don't do that in a function. Function works with its own variables, and it would change stuff within its own body.